Okay, we're going to do the examples now. And the examples, when you're looking at them, again, I'm hoping that you have some appreciation for what's being asked of you. Again, I'm not saying it's easy for you to do, but the bottom line is you should have some appreciation of what's being asked. And what's being asked, you're being asked to verify that these things are identities. Although it may be conditional, you're being asked to verify that these are true statements. All right. However, they may be conditionally true. There may be conditions under which not true. I'm not too worried about these, little tiny conditions. And certainly, as I go through the problems, I want to emphasize that we're not looking for that level of detail at this point, but later on, that level of detail is going to become more apparent to you. That although we say something is true, it may not be totally true. Right? These are conditionally true statements. We're just looking for simple manipulation to get through the problem set. All right. So I'm going to switch over now, and give me a second. I'm switching over to a whiteboard now. So, when I do number one, certainly I'm going to write it down for you. But, if I were looking at this problem over here, the first thing I would do is recognize that for me to verify an identity, what I have to do is I've got to look at one side and the other and decide what side do I want to work with? Which side allows opportunity for working? So I'm going to say the left side does. So let me write this down for you. It's cosine. Sorry about that. It's the cosine of theta times the secant of theta minus the cosine of theta equals the sine squared of theta. So my claim over here is that in number one, what you're doing is looking at this thing and saying, I'm going to pick the side with opportunity that allows me to simplify that side in the hope that after I simplify that side, it'll look like the other side. So what side would you choose? I would say this side here provides a lot of opportunity for rewriting it. So what I want to suggest, at least initially, not that it always works, but write them as more familiar functions. I put this over here, cosine theta. That's familiar to me. Well, secant's a little odd, isn't it? So I'm going to say, what is that? Well, it's 1 over cosine theta minus cosine theta. It's familiar. Okay. What am I going to do now? I'm going to distribute the cosine theta across these two terms. And what would you get? Well, you get cosine theta over cosine theta minus, well, cosine times cosine is going to be cosine squared theta. All right, so I'm over here. Now, here's what I'm saying conditionally true. I'm not going to say cosine theta divided by cosine theta is always 1, but conditionally it's 1. Provided cosine theta is not 1. We're not looking for that level of detail from you. So what do you get over here? Well, the next step, I'd say this is 1 minus cosine squared theta. Well, I think you should recognize this. And what I mean by that, you should know that sine squared theta plus cosine squared theta is equal to 1. Or sine squared theta is equal to 1 minus cosine squared theta. So I'm going to say you should recognize this thing as actually being the sine squared theta. So what have we done? We've shown after simplification that's really the same thing as the other side. So we'll put down QED. We showed it's supposed to show. Again, this is conditionally true. We're not worried about the conditions that it's true. All right. So what I want to do next is go to the next problem. All right. So we just did number one. We'll go to problem number 2 now. All right. Number 2 looks nightmarish to a lot of students. And what I mean by that is a lot of students look at that and say, I don't think I could do that one. Of course you can do that one. So I'm going to pull on the side. And I'm going to work with it. It's tough though. I'm not saying it's going to be easy for you. So someone says, what side would you pick? That's up to you. But I'll be honest with you. If I were looking at it, the side I would pick is the right side. And why is that? There's 2 terms. And what I could do something with those 2 terms. And what could I do with those 2 terms? I could add them together. By the way, I know it's subtraction. How do I do that? Common denominator. Again, you would need to know basic algebra to do this. What's that going to be? Well, it's going to be 1 plus sine x, minus 1 minus sine x. Well, I'm going to keep going forward. And I have to. It doesn't look anything like the other side. Let's keep going forward. So what do you get on top? Let's see. You get 1 minus 1 is none. Sine x minus a minus sine x is 2 sine x. Again, it still doesn't look anything like the other side, except for the 2. Now, what do you get on bottom? If you multiply that out, what would you get? You would get 1 minus sine squared x. Still does not look like the other side. I want to keep going. Keep looking at this. And I'm going forward now. So 2 sine x. And what's the bottom going to be? Well, we kind of just did something. It's Pythagorean identity, right? It's just simply cosine squared. I want to point out it still doesn't look like that side. I'm going to keep going. And what do you see? 2 sine x over cosine x times cosine x. I know it's a lot of work. What I'm going to do over here, 2 is going forward. Let's see. I'm going to circle this for you. What's sine divided by cosine? Well, you should know it's tangent. And what's 1 over cosine x? It's secant x. All right, let me shrink this out a little bit. I want to point out, what am I looking at? This now is exactly what we want it to be, that thing over there, QED. I know some people argue, say, I can do that faster, or it takes me longer. You have to follow a path that other people can follow. It's so important you can do that. All right, let's go to the next question. And I guess I'll do number 3 now. Put off into the side. Oh boy, which side to pick now? I'd say both sides provide opportunity. Now someone says, why if both sides provide opportunity, why can't I just pick any side I want? And here's the answer. You can pick any side you want. The side I pick may be different than yours, but here's the deal. When you pick a side, you need to stick with that side. If it's not working for you, erase your tracks and go to the other side. Well, what side am I going to pick? I'm going to pick the right side. Well, I'm sorry, left side. Now, this is going to be tough. Cosine of u, 1 minus sine of u. Gee, what can I do there? Well, you know what? I think I'm going to multiply top and bottom by the bottom's conjugate. Who knows? It might work. We've done something like this in Math 100 with irrational numbers. Let's take a look what you get over here. You get cosine u, 1 plus sine u on top. No, I didn't multiply that out. On bottom, if you multiply that out, what do you get? 1 minus sine squared u. All right, so I'm going to say that wasn't so bad. It doesn't look good, though. It still doesn't look like that right side. Let's keep going. Cosine u, 1 plus sine u, and 1 minus sine u squared is cosine squared, which means cosine u times cosine u. And repeat that. 1 minus sine squared u is cosine squared u, which is cosine u times cosine u. What's nice about this? Although conditionally, these things cancel off. All right, let's keep going. I'm going to split into 2 terms now. What are you going to get here? 1 over cosine u plus sine u over cosine u. What do you get over here? Secant u, and sine over cosine is tangent of u. Let's look at the original problem. I want to point out we're seeing it, QED. All right, that was number 3. Let's go to number 4. Now, granted, I realize for some students that, oh, this goes too quick for me. I can't follow. You know what? You might have to watch those little spot videos on the side. So let me get my eraser around. I think there's a doohickey over here. And I'm going to copy this one over here. And I'll pull it on the side somewhere. All right. By the way, that's the Greek letter delta. It looks kind of crazy looking. I know that. When I type it, I get a really good looking delta. Unfortunately, when I have pretty bad penmanship, my deltas really don't look that good. But let's go for the work. What's the work? Well, you got to pick a side. So I don't know what side to pick. Well, pick any side. This time I'm going to pick the right side. And let's go forward on it. I kind of like that conjugate thing. I'm not going to say it's going to work for me, but I kind of like it. But I'm looking at that top, and I'm thinking it's Pythagorean, right? Tangent squared. Let me write that down for you. All right, I think I've seen this before. So sine squared theta plus cosine squared theta is equal to 1. You could divide both sides by cosine squared. You would get tangent squared theta plus 1 equals secant squared theta. So the tangent squared theta would be secant squared theta minus 1. All right, so let's take a look at that. So I'm going to write tangent squared a little differently. I'm not saying it's going to work, but maybe it's not going to work. So I'm going to write down that tangent squared is actually secant squared delta, not theta, minus 1 over secant delta minus 1. Well, what do I notice immediately? The top is a difference of perfect squares, so it's going to factor secant delta minus 1, secant delta plus 1, all over secant delta minus 1. All right, something cancels conditionally, and this cancels conditionally. Now, someone could say it still doesn't look like the other side. Let's not worry. What are you doing? At least you're moving forward. So I want to say it really kind of worked out really simple. But again, I'm looking at that and I'm not seeing it. So what I'm going to do is say, if I'm looking at the left side, it's definitely in terms of cosines. So I'm going to write this over here. What is it going to be? 1 over cosine delta plus cosine delta over cosine delta. And what does that give me? 1 plus cosine delta, sorry about that, over cosine delta. Let's see if we got it. Wow, look at that, miracle. Exactly what we expected to get, QED again. By the way, moving forward is an important characteristic. You want to move forward, including if you're going in the wrong direction, keep moving forward. You'll know you're in the wrong direction at some point, and then you may have to backtrack. You still have to go forward at some point, though. Maybe another direction, but go forward somewhere. So where are we now? I guess we did 4. Now we're going to look at number 5 now. All right. It looks nightmarish, no doubt about it. I'll pull it aside for you. And I got a lot of work to push this around, don't I? Blow this up. Around a little bit. I say this is a no-brainer, this one. And someone says, why do you think it's a no-brainer? I think I know what side to pick immediately. What side provides opportunity? It's got to be the left side. There's no choice. Choosing the 0 and trying to rewrite, look at the other one, that's really not going to work out too well. I'm not saying you couldn't do it. It just doesn't seem like a good chess move at this point. How do I do this? Common denominator. Well, let me write that down for you. A lot of work. I'm not saying it's going to be easy for you. Let's see, cosine x minus cosine y. This is why it's so important you have an algebra skill to be able to do this. Let's see. That doesn't look good, does it? I'll tell you why it doesn't look good. It doesn't look anything like 0. I don't know, let's keep going. By the way, the only way a fraction could be 0 is if the top becomes 0. I'm going to multiply it out. Again, we're doing the top. All right, let's keep going. What do you get in the top? Cosine squared x plus cosine x cosine y minus cosine x cosine y minus cosine squared y. Whoa, I got more work to do, don't I? Plus, well, it's going to be a lot of work. Sine squared x plus sine x sine y minus sine y sine x minus sine squared y. I got to shrink this thing down, don't I? Well, I notice a lot of things just disappear. For example, these two disappear. These two disappear. And now I'm going to look at something here. I'm looking at this. And I'm looking at this. If you were to add those two together, you get 1. I'm just copying the bottom over again. Whoops. Let's see what you get there. You get 1, right? Put it in blue. All right, let's look at this guy over here. Let's read another Pythagorean identity. What would that be, minus 1. Lo and behold, we have what we want. What do we want? We have 0. This becomes 0. What have we done? We did it. Q, E, D. All right, let's go to the next page, which would be number 6 now. All right, let's take a look. Wow. I want to point out there's Sage code over there. Let's not worry about that, but I do see it. And the Sage code has to do with how to verify that identity using Sage. We need to do things by hand, though. We're not using machines to do these problems over here. We take this problem here, pull it to the side, and let's get to work on it. Verify the identity. What side would you pick? I'd say this side would be a good side to pick. I need to work on it. Someone says, what's the work going to be? I'm going to try something. I'm going to try to factor it. 1, 1, cosine squared, minus, minus. Let's see if that works. 1 times 1 is 1. Then you get minus 2 cosine squared. That worked. And then you get plus cosine to the 4th power. That's good news. Let's go to the next step. I'm going to say these are Pythagorean identities. 1 minus cosine squared is sine squared. And 1 minus cosine squared is sine squared. Whoops, sorry about that. I was going to write that down twice, but. One factor, 2 factors, followed by another 2 factors is 5 factors, right? QED. All right, let's go to number 7. They have the Greek letter epsilon there. I'm going to pull them aside. And this thing over here, it's your last problem, by the way. And he said, hey, what side are you going to pick? I can't say that in experience you'll be able to pick the right side all the time, but I don't know. I'm going to pick the left side. Again, you're free to choose. All right, let's do it. Many ways to do the problem. I'm not saying the only way to do it is the way I'm doing it. There's many ways to do it. The only goal I have over here is I've got to get it to look like the other side. So I'm going to write this down. Sine epsilon 1 minus cosine epsilon. And I hope you remember in the past we use these conjugates. And what do you get there? Well, you get sine epsilon times 1 plus cosine epsilon. No, I didn't multiply that because my goal with the conjugate is to get the bottom as a Pythagorean identity, by the way. So it's going to be 1 minus cosine squared epsilon. And I know that to be something, right? What do I know that to be? Sine squared epsilon. And what do you get on top? Sine epsilon times 1 plus cosine epsilon. One of the signs cancel off. What do you get? Sine epsilon in the bottom and 1 plus cosine epsilon on top. That's exactly what you want to get right over there, QED. All right, that pretty much covers it out. And I know it's tough. It's going to take a lot of work on your end, by the way. It really does take a lot of work.